Air quality is one of the most important factors in the laboratory. It really can make or break your outcomes, your blastulation rates, your pregnancy outcomes, biochemicals, etc. And I think there's no better person than Jason to actually give us insights into how it affects embryological outcomes.
So just to expand a little bit on the discussion thus far and talk about air quality, clearly the lab has evolved immensely since sort of the early days of IVF. Here you can see an example of arguably perhaps the first clinical IVF lab with a box incubator and a bell jar inside, and really a modified research lab. Fast forward to now, we saw that amazing video at the beginning of the webinar and some of the images and slides thus far showing a modern IVF lab. And so this is just a representative example of a modern IVF lab in the States, and covering many of the things that we've already talked about here: the vinyl flooring, low VOC adhesives, solid surface stainless steel, powder coated metal cabinetry, IVF specific supplies. You can see in this particular lab dedicated centralized HVAC with those diffusers up top. And sort of this workflow optimized layout around a central working unit with ICSI stations and workstations sort of spread out to avoid any bottlenecks. So sort of thinking through that process, you can even see some of the nice centralized gas manifolds there. So many of these considerations are based on trying to maintain good air quality. And we'll talk about some of those points now. And really, just to reiterate what most of us know, the reason we sort of obsess about many of these things is because of the sensitive nature of the gametes and embryos that we deal with. And a modern IVF lab with all of these specialized considerations and attention to detail can help reduce those stressors. Modern lab equipment, but for the purposes of today's talk, lab design, quality control, again, attention to detail, is critical. And you can see a variety of those cell stressors that many of us have lectured about or are very well aware of. But for the purpose of this talk, we're really going to be focusing on sort of the toxins and pollutants that can be in the air. And this is an issue in some locations more than others, but an issue nonetheless, and something that everyone should be aware of, and that there are methods at our disposal to address the stressor. So I like to sort of highlight existing literature for people to sort of go back and read up further and do a deeper dive than what we can cover here in a 10 or 15-minute talk. And this is one of the more recent publications. So a really great consensus that's been going on for the last several years out of Cairo with Mohammed Fazi and colleagues and David Mortimer, Jacques Cohen, and sort of a who's who of IVF contributing to this particular publication, talking about this very topic, air quality and other topics. So suggest you pull this up and read this if of interest. And there's any number of other book chapters out there that also cover this topic in detail. So as we've sort of discussed at length already, proper lab design and execution are critical to maintain air quality. We talked about proper building materials, insulation, paint, flooring, the adhesive in the flooring, the type of cabinets, all critical, because if they aren't the proper material from a VOC or air quality perspective, all of that pollutant is now inside your lab. And if these labs are sealed up, as we've talked about, they have no way to escape. So you want to then have a dedicated HVAC system, meaning some way to sort of clean that air. If you have a centralized HVAC system, it's isolated from the rest of the space, so you're not pulling in dirty air from an OR that might be using some toxic disinfectants, or a waiting room that maybe isn't as well policed in terms of the low VOC building materials. Cleaning the ductwork, you don't want to spend all this time and energy sort of designing and building this lab to then put in ductwork that's dirty, covered with oil, VOCs that are now blowing into your lab. Proper air exchanges, proper filtration, whether it's HEPA filter or a carbon filter, a permanganate filter, or a mixture of these. There's different combinations of filters to address a local particular issue that may exist depending on the outside air quality or the local circumstances. And then having a system that ideally can maintain a stable temperature, and as we've talked about here, humidity, if that happens to be an issue. So we can talk a little bit in depth about some of these things, and it will vary by region in terms of cost, as we've mentioned, some other local considerations. And then in terms of air quality, this also carries over to the gas supply in terms of the gas tanks being a potential source of VOCs and some filters and steps that can be taken to address those. And as I mentioned previously, during the construction process, careful and constant oversight and attention to detail is required to ensure that you're getting the end product or the lab that you designed and put so much time and energy and thought into to make sure that it's actually executed to the level that you have expected. So I think most of us would agree that air quality is something we devote a lot of time, energy, and money to. And so I'm often asked, do we have data to support these suggestions? And while I don't have any personal data, the nice thing is Jacques Cohen and others certainly have looked at this over the years, and I can present some of their data and let you draw your own conclusions, or at least have background as to why we sort of have arrived at the place that we are currently. And for obvious reasons, with the topic of this talk, air quality improvement approaches have a major impact on lab design and cost. So it'd be nice to know how important is this. There are several anecdotal reports that changes in air quality can negatively impact outcome, which is why we're concerned about it, and rightfully so. But the first paper published that started this can be seen here from Antonia Gilligan, the expert on this, and the person who really sort of championed this early on with dedicated HVAC systems, and Jacques Cohen and Tim Schimmel and others. But I think it's key to point out here that in that first publication, this was far from conclusive. You can see the authors themselves indicated the impact of ambient air and its potential effects on conception. And that's not that that's wrong. Many of us are concerned about potential effects and trying to get ahead of this. We don't necessarily want to be proven that something is detrimental before we react to it. So certainly, I think indicated to be cautious about this. And so here's sort of one of the graphs presented in that paper. You can see them tracking clinical outcomes, and there'd be a drop in clinical outcome and another drop, and they sort of correlated this with certain events, whether it be pesticide spraying or other things that could potentially impact air quality. And then they showed when they changed air filters, which presumably would improve air quality, they'd see a rebound or improvement in those negative outcomes. And this isn't a one-to-one ratio. You can see there was sort of a decrease here, no real explanation, no filter change, some decreases here. So certainly not definitive, but again, a reason I think to perk up and pay attention and say, hey, might there be something here in terms of air quality and its impact on embryo viability and outcome. Here's a more modern graph really showing that same thing. And this is from a commercial entity, but similar sort of thing where they are tracking clinical outcomes, and they'll see a drop and they'll coincide it with some external event. In this case, road resurfacing, in this case, insecticide spray, area of construction. Now, the key is these cannot be controlled by the IVF lab. We can't control what, municipal facilities are doing in terms of roadways or parking lots and things. And oftentimes we can't even control what they're doing within our own building. Other tenants have the right to sort of construct their space. And so the nice thing is we need to sort of protect ourselves, buffer ourselves, and put in systems that give us a little bit of leeway to address these things as they arise. But again, this isn't conclusive data. There are other decreases here with no sort of seminal outside events postulated to be the cause. And importantly, there's no measurements of air quality. So there are assumptions that air quality sort of led to these decreases. When there's no measurement of VOC levels, you can't necessarily draw that conclusion. So far from definitive, but again, certainly leads us down that pathway. And then just quickly, here's another example of sort of clinical outcomes shown here before or after implementation of an air filter, and across the board showing an improvement in outcome with inclusion of this air filter. Again, no measurement of air quality. So whether that was the only variable that was changed before including an air filter or not is unclear. But here they would like you to believe that simply improving air quality improved outcomes. But often the case, if you're adding a new air filtration system, that means construction. Normally other things have changed: equipment, workflow, other materials. So again, leads us down that path, but not necessarily conclusive. And here is another peer-reviewed published concentration out of University of Iowa, very well-respected, high-performing program in the U.S. And here what they did was interesting. They looked at these clinical outcomes for fertilization rate, cleavage rate, and blast conversion rate over a 3-year period. And they did this to control for change in seasonality. We know that the seasonal changes can impact domestic animal reproduction. And so sort of taking that cue in terms of hot, cold, or other factors. If it's cold and your HVAC system is running your heat, that could impact outcomes, perhaps VOC levels. And so they try to control for those other variables by looking at the same time frame over this 3-year period. And so they essentially looked at a time period where a carbon filter was present, time period where the carbon filter was absent, and a time period where the carbon filter was placed back. And so in this middle red area, they discovered that the carbon filter had been removed by maintenance and never replaced. And so what they saw was higher outcomes, a decrease when that filter was removed, and then higher outcomes once it was replaced. Again, suggesting that air quality or this carbon filtration was improving outcomes. But again, no measurement of VOCs to sort of indicate that air quality was improved or not with placement of this filter. But it should. That is the function of that filter. So the nice thing is, if air quality is impactful, and I think there's reason to believe that it is, there are means to improve air quality within the IVF lab. And we've talked about some of these: centralized system, different sorts of filters depending on what the issue is, different approaches to break down VOCs, which are the main concerns. They do have to be set up specifically. Again, that attention to detail, using experts on IVF HVAC systems are helpful. You can build these from scratch, but becomes a bit more difficult. So there are these sort of IVF specific plug and play units that help with this. So that makes it easier for us as the end user. And now then specifically for embryologist perspective, VOCs vary by location. And again, Jock Cohen and others sort of showed this nicely. Some locations have very poor outside air quality with higher VOC content. They might have to use a different approach than others. Different areas may have different air quality depending on construction materials, things like that. Inside the IVF lab, we hope we have the best air quality. But interestingly, you can see in this publication from the late 90s, inside the incubators had a very high VOC level. And that's probably because of plastics and other things, and they were accumulating inside the incubator. And that's probably the area where we're most concerned about in terms of VOC quality and the negative impact on embryo development. So we should really pay particular attention to that. You can start by making sure that your lab has good air quality, and that's not sort of infiltrating your incubator. You can off-gas supplies if you so choose, but many of these IVF supplies are sort of have been improved and pass bioassays and mouse embryo assays and things from the manufacturers that we buy them from. But many of the modern incubators have internal air filtration specifically for VOCs. You can see one example here. So that's a nice addition. You can even convert existing older incubator technology by putting on some of these external VOC filters and particulate filters. So whether the VOCs are coming from plastic material, the lab itself, or even the med gas supply, which is sort of another area of discussion, these filters can help address some of that to make sure that they're not accumulating in your incubators. Finally, you've spent all this time and energy to maintain good air quality in the lab. You want to make sure that when you clean and disinfect your lab, you're not reintroducing those VOCs. So just different sort of approaches to make sure that when you're cleaning, using the proper cleaning supplies that are VOC free or low VOC, and then monitoring, validating that your procedures aren't inadvertently sort of compromising air quality. So I think we can agree that air quality is important, likely impacts embryo development. Taking prudent preventative measures when you're building a new IVF lab is really the standard of care. Centralized or modular HVAC systems, appropriate building materials, off-gassing and burn-in prior to use, using a proper bioassay, proper cleaning products, gas filtration, and med gases or incubators are sort of the standard of care at this point. And so really, I think that sort of summarizes air quality and why we pay particular attention during design of the lab to make sure we start off on the right foot. And then, as we heard previously, constant monitoring and oversight to make sure that you maintain that good air quality after you've completed your initial